So now that we've had a chance to talk about web MVC and web Flux a bit more, I want to return back to the monolithic flight application that we've been using as a case study and explore it in a bit more detail and dive into some of the implementation aspects and also show you how you can run tests that mock an actual client server application when in fact there's no network involved. And so what I'm going to do is I'm going to sort of dive first into the flight controller, and we're going to take a deep dive into a couple of the methods that it defines. And I'll show you first what these methods do at a high level. Then I'll show you where these methods get called in our test program and how they emulate what would actually happen if you were running this in a real client server environment. And then we'll explore the implementation of some of these methods because there's some pretty cool things that we can show there. Keep in mind that we're still living in the kind of synchronous world for the most part. We'll show some object-oriented stuff. We'll show a little bit of functional programming stuff here, but we're not going to start going hog wild with the reactive programming yet. That'll come later. So this is the flight controller. You can see it's annotated as a REST controller. And what that means, as we talked about before, is that tells the Spring framework to connect it up with a dispatcher servlet and a handler and so on, so that incoming HTTP requests get mapped to the appropriate handler methods or endpoint methods that are here. And let's just take a look at one of these endpoint methods. This is flights, and you can see flights is just a symbolic constant that is the flights string. And so you can see that we use the mapping. So this method, this find flights method, is going to be handled as a get. It's going to handle get requests. And lo and behold, when you actually look at the method itself, you can see it takes 4 parameters in this case. And these 4 parameters are the departure airport, the departure date, the arrival airport, and the currency that you want the result to be delivered in, or the results to be delivered in. So that's find flights. And then, as we'll talk about the implementation in a minute, but real quickly, we just forward to the flight service find flights method, which only knows about Java. This kind of adapter method knows about a bit about the fact that we're getting HTTP GET requests. And as you can see up here, we auto-wired the flight service to be connected to the implementation of this. And then I'll again just also show you very briefly, we have another method here called find best price. It's going to take the departure airport, the departure date, the arrival airport, and the desired concurrency. And it's going to go try to find out what's the best price, which there could be multiple airline flights that have the same best price, but we're going to get back a list of flights that are the best price. And that also just forwards to the flight service. So how do we actually call this stuff? If you go over here into the tests folder and you click on flight controller tests, you'll see that we have our flight controller test, and we say it's a Spring Boot test, and it uses some mocking mechanisms, and it has some usernames that you can use because we have authentication built into the example now. And here's the test for test find flights. And what this does is it goes and it uses this builder to build up a list of flights. And I won't go through this in detail, but this is a really cool little file a little class that will build random flights with destinations and departure times and arrival airports and departure airports and prices and all that good stuff, and airlines and so on. And then we're going to iterate through the list of flights that we have just created, and we're going to take each flight, which corresponds to something that's actually available to be found, and we're going to go ahead and reverse engineer the flight request that would request that flight. So that's sort of a subset of the information. It just needs the departure airport and the arrival airport and the departure date and the currency, not all the other stuff. It doesn't know about the airline. It doesn't know about the price, doesn't know about other things. It's just the things you need to make a request. And then we add that to an array. And then we use a mocking stubbing method called when that says when find flights is called, go ahead and return the results into this expected list. And then here's what I wanted to show you. So now we're going to go ahead and mock a call to the controller. And what we're doing here is we're using the mocking frameworks. This particular test doesn't actually run across the network, although it could if we set it up to do that. But we're just mocking it locally just to make sure it's working properly. And so what we're doing here is we're building a GET request. Remember the find flights method and the find best price method, or the endpoint methods that we define on the controller, they're GET requests. So we have to create a GET request. So here we're going to build up the flights. We're talking to the flights endpoint, and we go ahead and we build up the query parameter, which we can do either this way or perhaps more formally that way, shown below, that's commented out. And so we go ahead and build up the URL or the URI, and we put in the departure airport and the departure date and the arrival airport, the currency, and so on. And then we go ahead and make the call, we get the result, and then we return the result as a string, which will be JSON, because that's how it comes back to us, since it's a GET request and a GET response. And then we do a little magic to convert this into a canonical form. And then we verify that we indeed did call the find flights method one time. And then we check to see that the results that came back from our GET request on the flight controller match the results that came back when we called the service directly. And this is kind of cool, because this is demonstrating how you can have the service help for testing to make sure that other parts of your code are working properly. Because quite frankly, this kind of stuff is tedious and error prone to write, which is why there are templates to help you do that, to avoid the complexity of that. So that's the test find flights. There's also a test find best price, which works pretty much the same way. We just use query param here to clean it up a little bit, so it does all that crazy encoding into the query string. And same basic idea. We're just checking to see whether what we get back from the controller is what we would expect to get back if we were to call the service directly. This particular test is assuming that the service is doing the right thing. So we're kind of testing to make sure that the controller is working properly. Okay, so with that in mind, now let's go over here and do a little deeper dive into what the controller does when it gets that GET request. Obviously, the parameters we put in there are delivered to its endpoint method through these request param annotated parameters to find best price, which is what we use as the method to implement this endpoint. And then we go ahead and forward to find best price. So let's first take a look at find flights. That's the first one we're going to look at. So here's what find flights does. And this is actually pretty cool. And it shows off some very powerful functional programming, but still synchronous programming. So we're not using reactive programming. We're not using asynchronous programming. We're using synchronous functional programming in the form of Java streams, in the Java streams framework. So what we do is we say, so this is the implementation of find flights. We say, hey, airline service, go ahead and find me all the flights that match this departure airport, departure date, and arrival airport. And lo and behold, under the hood, you can see this is just a very simple adapter that goes from the world of Java, business logic, into a method call on the JPA-enabled persistent repository, which we automatically configured based on some information we provided in the resources portion of the program. So that's going to go and do a database query and give back all the flights that match that particular set of parameters. That comes back as a list. So we have a list of flights. We then convert that into a stream of flights. And then we do something super cool here. We take that stream of flights and we use the collectors grouping by collector factory method. And what that does is that's going to create a map that will map the currencies. It'll map all the currencies that came back. Let's say we went and looked up flights with, Lufthansa airline and Nippon Air and, British Airlines and American Airlines or whatever, right? So maybe 4 different currencies. So each of the prices that come back from those different airlines from that database lookup, those database lookups we saw, they're going to come back with different currencies as one of the fields. So we're going to group the results by currency. So we have a map of currency to list of flights with those currencies. So all the US dollar flights will occur in one part of the map. All the British pounds will occur in another part of the map. All the yen or all the euros will occur in different parts of the map. All right, so now we got a map where the keys are currency. And then we go ahead and we convert that map into what's called an entry set, which is just basically a set of map entries, which are key value pairs. So key being currency, the value being the list of flights that match that currency. We then turn that into a stream of entries. And then we use the Java streams flat map method. And what we're going to do is for each entry that we have, we're going to convert the currency from the currency it's in to the currency we want the result in. So let's say we want all the currencies to be in US dollars, or we want all the currencies to be in British pounds or whatnot. So we have indicated that by the parameter that we passed in here from the client, which ultimately would probably come from a GUI. So we're going to call this method called try to convert currency, passing in the from currency, like what it's currently in, the currency we want it to be in, and then we want the list of flights as a stream. So we're going to call this try to convert currency method. And you can see try to convert currency takes the from currency, the to currency, and the stream of flights. And if the currencies are different, then we're going to do something. If the currencies are the same, if they're in dollars and you want them in dollars, it's a no-op. We just return the stream. But if they're different, we go and we talk to the rate service and we say, please tell me the current exchange rate from this currency to that currency, from pounds to dollars or euros to dollars or whatever. And that gives us an exchange rate. And then what we do is we say, hey, flight stream, I would like to take every flight you have, and I would like you to multiply the current price of that flight by the exchange rate and update that element. So we've kind of changed the element in place, if you will. We've actually replaced it, but the idea was we've created a new stream with the updated prices. That's the new flight stream, and then we return flight stream as the result. So it'll either be the same thing that we came in with if there was no currency conversion required, or we will have converted all the currencies. So you'll see here when we're all done, we'll now have a stream of flights with correctly converted currencies, which we then collect into a list, and then that's what gets returned back to the caller as the return value of find flights. So I think that's pretty cool, right? So we're showing off a bunch of stuff, right? We didn't have to worry about converting the request from, whatever the client did, which could have been in JavaScript for all we cared. It turned it into an HTTP request. The servlet and controller infrastructure of Spring turned that into a method call on the controller. That got forwarded to the service. The service goes and does a database query, which from this point of view looks like a Java call. Then it does a little bit of stream magic to turn the elements into a map. Then we convert the elements in the map to make the currencies correct. And nowhere do you see really any imperative programming for the most part, right? We're using streams. There's no loops. There's no branching. It's all very much, declarative as much as we possibly can. The one and only real limitation with this approach is it's still synchronous, but that's okay. Well, it's actually absolutely trivial to make this not be synchronous by just using a parallel stream instead of using a stream. We will talk about that later, but that's just a heads up. We could go ahead and do a lot of the processing for that implementation in parallel. The next thing I want to show you is the implementation of the find best price method, because this is also a really fun example too. So here's find best price. So find best price, when it's called, it calls off to the airline service and says find the best price. So let's go take a look at that. And this is going to illustrate some really, really cool things about services calling services that then will call into the model layer to get the data and then do some processing and then return results. And it's all very clean. And once again, it's very declarative for the most part. Still object-oriented in parts, but it's declarative. It's object-oriented in its structure, but it's functional in its behavior. That's probably the easiest way to think about it. So here's find best price. We take the departure airport, departure date, and the arrival airport. And the first thing we do is we say, go find me the list of flights. That was exactly the same call we'd done before. That goes and does that database query. But notice we didn't really write any database code. We just wrote the schema, and we annotated some data structures to make the repository automatically. And here's a really fun algorithm. And I'm going to show you a couple of variants of this shortly, but this is to start off with. So we got our list of flights back. And now our job is to find the flights with the best price. there might be one, there could be many. And here's how we do it. First thing we do is we take the list of flights and turn it into a stream of flights. And then we use the stream's min intermediate operation to find the minimum price. So that will do basically a linear pass through the stream, finding the minimum price. And if we have if we looked up flights that had that didn't have any, if we looked up a flight request that had no flights that matched it, we're going to get back an optional that will be empty, in which case we're going to return null. Otherwise, we're going to return the flight that we have. I mean, the price that's the minimum price. We do a little sanity check here. If min is null, we return null. We could probably do a better job to get rid of nulls, but we're not talking about optional sanity checks here. We're just trying to make the code do something cool. So now, assuming we found the minimum price, check out what we're going to do now. We're now going to go ahead and turn the flights list into a stream again, and then we're going to filter for all flights that match min. So if the flight matches min, if the price of the flight matches min, we let it go through the stream, through the filter operation, which is called a suppressing operation. And if it doesn't match min, we ignore it, we discard it. So what we end up doing here is we end up collecting the results of the min price into a list, which could have one element, could have n elements, depends how many things match the min. And so that's what then gets returned from calling this. And that then, of course, comes back here. So we call it airline service, find best price. Then that returns as the result from this.
Is there a streamified way of doing that without touching everything twice?
Good question. So I will cover that in just a second, but it's a great question. That's going to be the next video. And the answer is yes. And I will show it to you.
Yeah, I thought so. I've taken a couple of your streams-based courses. I couldn't do it off the top of my head.
Oh, it's badass. You'll be very impressed, I think, when I show it to you. It's really cool. It took me a couple of hours to figure out how cool I could make it, but I'll show you that in a second. So basically, that's kind of what I wanted to show you today. In subsequent sessions, we will continue to look at this example because we're going to focus on things like security. There's a whole bunch of stuff in here having to do with security. There's a whole security package that does the security for this stuff that's pretty well documented. We'll cover that when we get to security later. And we might look at this for a few other reasons, but I think we've pretty much covered the bulk of what there is to show in this implementation that's interesting. And hopefully you get a better sense of how easy it is to program this stuff, because most of it looks a heck of a lot like regular Java programming without having to futz around with all the low-level details of web programming and HTTP and all that other good stuff. But to be fair, this implementation, while pretty clean and concise, is very much limited because it doesn't really have support for concurrency. Everything's running in one process. So later examples will really flesh this out and we'll look at it in more detail.